All right. So, we have two additional tables that you can use to design the beams, because as you know, if you do not know the uh, the beam section, but you know the unbraced length, and in the moment it becomes a little bit difficult because you don't know the size, or you don't know which LB and LI is going to be, so you cannot possibly tell what section you are going to use, even if you have moment. So generally there used to be a design curve, because let's see, if not this one, if you have the beam like this and you don't know what section is, you need to know the section first before you can tell the specific unbraced length is going to give you how much moment. Okay, so if you don't know what section you are going to use, you have the LB as an even though if you know LB, you don't know LP or LR, right? So generally there used to be a design curve, and I still have that design curve. If you want to have that, you can ask me, because I don't have it available in the PDF file. You're just going to have to make a hard copy of it. But I now have the table C and D created from those design curves. It works the same way, except it's not a picture. Okay. Now, so let's say if you have a case where you know the unbraced length and you need to pick up the member, you need to look at these tables. Okay. And no, not this one. Sorry. The way the table works is like this. Let's say if after, oh, where it is, excuse me. Okay, here it is. Let's say if you know the that your unbraced length is equal to 6 meters, the way that I have with my with the design that I shared with you in the beginning. So if I already know the unbraced length is 6 meters and I have my beam, right? Say the 12-meter beam that I have as an example, then they have the load. And from this, I can calculate my moment, right? I can calculate my moment. I know how much it's going to be, and I know my LB. So I can always come down and look at this and until I see the moment that I need. Okay, this is nominal moment. So you may have to enter this table with, say, after you know MA, if you use ASD, you multiply your MA with the factor of safety. And this should not be greater than your nominal moment. Now you can pick your nominal moment. Okay, but as you know, you have the CB, that's a helping hand. So you can use the CB to help reduce your value here as well. Divided by CB. But what does this CB tell you? CB, the table. This is the CB back calculated to tell you how much you can actually use CB, or how much CB you can actually use before your moment multiplied by CB exceeds MP. Okay, for example, I believe that if I remember correctly, the section that I use is this one. Okay, and this is the table where the unbraced length is equal to 6 meters. So with unbraced length equal to 6 meters, I know that this section can carry moment equal to 40,500 kilogram meter. And if I multiply by CB equal to 2, this multiplied by 2 will be exactly equal to MP. If you don't believe this, you can go and take a look at this table C right here. Table C is just like a typical table that sums up the behavior or the properties you need to know about each section. So you can look at table C and go to this section. Excuse me. Go to this section. Okay, 500 by 200 by 89.6, and that number is for SM520. You can look at MP. So that's roughly, you know, 40,500 multiplied by CB equal to 2. So that tells you that, see here, 6 meters, that's your moment, and that's 2. If you have CB exceeds 2, your moment will exceed MP. So that's the meaning of it. If you calculate CB and you get like 2.2, for example, you know you will reach MP. Okay? So if you know that if you calculate your CB and you get like 9.6, you know that your moment capacity for, you know, 6 meter unbraced length will become this moment multiplied by CB. That confusing? I hope not. Okay, so let's say, no, I should go back to table C first, table D. All right, so that means your moment, your moment capacity is equal to, for this beam, for this unbraced length, 40,500 multiplied by CB, and M will not exceed MP as long as CB does not exceed 2. Okay, when you have CB exceeding 2, that means you have reached MP and you cannot go beyond that. So this is the usefulness of this number. You know how much CB you can use. Okay, if you have less CB than this number, you can use your CB freely. If you have your CB greater than this number, it means that you already reached MP. Okay, and notice that we have the green color here. This green color up top means that you are in the elastic region, and you can notice that when you are in the elastic region, it doesn't matter what steel grade you guys are using, you get the same moment. That's what elastic does to you. You know, the strength doesn't matter. Okay, and I also have another example from the I took it from last year exam, I believe. Right here. Okay, so example number 16, the last example for my session. It is, you know, the taken from the exam where you are asked to design the beam. So what will you do? You are given the the beam, and from this you can obtain your moment, right? And you should know that if we don't include the weight, which is, you know, self weight can be neglected. You know, I want to help you out, and you know, as usual, some just don't read, so they will include the weight, make their lives miserable. That's fine. You should realize that the bending moment diagram of this beam, you know, it would look like this. Do I have the area for it? It's fine. It's just right on top of this. The bending moment diagram should look something like this. Correct? And it's a symmetric structure. So you should see right away that, you know, region, you have two regions because of symmetry, region number 1 and region number 2. Okay, in region number 1, after the investigation, you have shorter unbraced length. So in region 1, LB is shorter, CB is 1.67, and it should be larger than the CB of region number 2. So you can say, or I can say, by inspection, region 1 will not govern. Yeah, by inspection is the very magic word. Before you can say it, you must be absolutely sure, and it must be said based on reason. Okay, and in region 2, is the region where you should investigate, and you have your M max here, correct? And you have a larger LB, so you calculate in region 2, calculate M max, and then MA, MB, MC, and CB. Now you have your CB, you have your unbraced length, you have your M max, you can start pick your section. All right. And you see, I am such a very good person that I give you LB equal to 2 meters as well. So that if you don't know, you're just going to do both. If you do know, this is what you need. Okay. And after you know your M max, you know your CB, you can start picking your section. And then you should re-investigate it as well with the LP and LR given. Okay. I don't have everything for me at the moment. You can try to do it yourself and see if you can obtain the right number. I also have the MR and MP for you guys. Okay. And, this example is pretty much the same as your design project, because in your design project, you would have your, let's say, I should write here to be more clear. In your design project, you will have the roof, the beam on the roof. I believe it's this case, right? So your LB is equal to L over 2. And it's okay if you want to simplify your question. And you have your beam coming in here. So that is also your brace point. So your CB is equal to 1.67 for sure. If you want to analyze the beam to include the self weight, you are welcome to do so as well. CB will be slightly different from 1.67, but not much. Okay, this LB in general it turns out to be 2.5 meters. So you get to do something with the inelastic region. However, for the second floor, you have so many, let's say, secondary beams like this, like 4 coming in. So I believe that LB, which is equal to L over 4, it's 1.25 meters. That's very, very short. So chances are you may end up with, the MP, because unbraced length is so short. So I believe that you have quite a few beams left to be designed for the next phase, which should not be due anytime soon, because what we all talk about today should be for the final. Okay, and that means you probably won't be studying this for a while, and I think that is more than enough to cover the design project. So that this should be the end of my turn for this class today. Next week, you will meet the head of the department instead of me. And yeah, that should cover this design project as well. Okay. So any question? Okay. So let me stop the share.